What is the Big Bang Theory? Approximately 13.8 billion years ago, the Bang occurred, and the universe has been expanding ever since. The Big Bang Theory is the leading scientific explanation for the formation of the universe. Some key concepts behind this theory include Einstein's theory of relativity, which explains the relationship between space, time, and gravity, as well as Hubble's law, which explains that galaxies are moving away from Earth at speeds proportional to their distance from Earth. Observations from the Hubble telescope have been key in producing evidence to support both of these ideas.
How does the Big Bang work? The Big Bang can't be entirely characterized as an explosion. It was just space stretching everywhere. The universe didn't explode or expand to become something, it was just growing into itself. As it expanded, it created a hot and dense environment in which energy became particles of gluons, pairs of quarks, etc., and were being destroyed and multiplied. Because we haven't covered gluons or quarks yet, just think of them as particles that help make up matter. Matter and energy were almost the same thing during this time, not just theoretically equal, and this is likely because of how hot it was. This brings up the famous equation E equals mc squared, which, in simple terms, says that energy can be mass and vice versa. Eventually, the small particles form atoms which clump together. With gravity's pressure, stars and galaxies were created. Although I've already brought up the famous E equals mc squared equation, there is one other equation that should be mentioned. The Big Bang in the very beginning can also be seen in terms of the Friedmann equations, which describe the expansion of the universe and its geometry. The Friedmann equations are the solution to the Einstein equations for the most basic universe. The main Friedmann equation helps relate the expansion of the universe from the Big Bang and the matter and energy density to space and its curvature. Similar to how Newton's laws give us F equals ma, the equation for the motion of objects, the Friedmann equation is sort of like the equation for motion for space. They help describe how the universe changes over time. Here's the equation. To help better understand the equation, we can briefly elaborate on the variables. The Hubble parameter, h, describes how fast the scale factor of space, s, changes over time. So, h equals change in s over change in t. Keep in mind that this is how the space is growing or has grown from the Big Bang. Rho, the p-looking variable, is the density of matter and energy, which help describe how space stretches through gravity. K is the term that talks about the curvature of space-time. This equation helps better the understanding of the Einstein equation. Matter and energy affect how space-time bends, which was what contributed to the Big Bang's expansion into the universe. This equation helps illustrate space and its growth during the Big Bang.